this is a great free response question, because if you study it and understand it, it covers so many different things that it will really help you with your comprehension and understanding of the calculus in general. This is a calculator allowed question, which you can almost see because of the different formulas that they give. They're not going to ask you to do any derivatives or integrals of those kind of formulas, but it is a calculator problem. So let's just kind of look at the problem and see what different things they are giving us that will probably be important. So they're walking, Mary and Chance are walking in the same direction along a straight path. So we're looking at motion along a line, so it's a straight path. We're looking at t between 0 and 20. They're giving me Mary's velocity, m of t, and they're giving me Chance's velocity, c of t. And they're telling me that both velocities are positive. That's important for t between 0 and 20. And they're giving us the units, which is meters per minute, because they're going to ask for units as part of the problem. And t is measured in minutes, which I guess we could have figured out because it's meters per minute, but that's redundant. Mary is 12 meters ahead of Chance at the beginning. So she's got a head start, and she remains ahead of Chance the entire way. Also an important piece of information. There's a lot of information in there. So let's kind of attack it one piece at a time. So looking at this, I'm trying to figure out what it is exactly they're asking me. They say, find the value of 1/10 the integral 5 to 15 of m of t dt. So that's Mary's velocity. Using correct units, interpret the meaning of this. That's the difficult part of it. Finding the actual integral right there, especially since we're allowed to use our calculator, should be a piece of cake. But what does this mean? Why are we trying to do that? So the giveaway here is that from 5 to 15 minutes is 10 minutes. Come on. It's 10 minutes. And we're multiplying this by 1/10. So I immediately thought of 1 over b minus a integral from a to b of f of x dx, a minus b minus a. That is the average value of a function. And let's just kind of talk about that for just a little bit, because again, the best part about this problem is that it covers so many different aspects of the calculus that that we could get an opportunity to think about it more deeply. So pausing from the problem for just a minute, I know that if I had values, 1, 2, 3, 4, 5, 6, 7, and I want to find the average, I would add them all up, and then I would divide by 7 the number of values that there are. Similarly, if I had a function here, so here's a function, and I wanted to find, and I knew the value at t equals 1, and the value at t equals 2, and the value at t equals 3, and the value at t equals 4, etc. And I wanted to estimate the average value. So I could take f of 1, which is right here, f of 1, and I could take f of 2, and f of 3, and f of 4. I could take all of these, add them up, and then divide by 4, because I have 4 different values, and I would have like an estimate of the average value. And I think you can see that if I did like if I added in f of 1.5, so here's f of 1.5, and then f of 2.5, and f of 3.5, I would get a closer estimate because I would have more values and I'd be dividing it by a higher number in this case, or 1.5, 2.5, 3.5. I would be dividing it by 7, and I would have additional values in here, and I would get a closer estimate of the average. Well, if you think about what does this represent? Well, this represents an infinite number of f of 1s, 2s, 3s, 4s, 5s. It's a whole bunch of them. In fact, it's every single one that's possible. So we're getting the total value here of the integral, and then we're dividing it by b, the upper limit, minus a. Well, it's written here as 1 over b minus a, but isn't that the same thing as dividing this by b minus a? Yeah, it is. So that's why this formula right here gives us the average value of a function. So I'm looking at this right here, and I'm saying, well, okay, so I'm not going to bother to do the calculation here of 1/10 5 to 15 mtdt. Actually, I changed my mind. I think I am going to calculate it. And what I'm going to do is I'm putting m of t in my y1, and I'm putting c of t in my y2. So at y1 is Mary's velocity, and y2 is Chance's velocity. So now I'm going to go I'm going to go to my main screen. I'll clear everything out of there. And what I need to find is 1 over 10 times the integral, alpha f2. I go to the integral, which is 4, from 5 to 15 of y1, alpha f1. So I don't have to type it in all these number of times, of y1, and that is dx, because I put x in instead of t. And I hit enter, and I get 54.409. I truncate, I don't round, 54.409. Oops, I didn't mean to do that. Okay, so this is equal to 54.409, but we have to interpret it. And so we have to write that that is the average value of Mary's velocity from t equals 0 to 20. So that would be the answer to A. And, please do what I say and not what I do, and make your work neat and straight down vertically. I'll try and do that for the other problems here, but I had to take this little detour right here to kind of over-explain average value. But so I would say the average value of Mary's velocity is 54.09 meters per minute. Don't forget the units. They'll dock you if you don't put the right units. And I left something out here. The average value of Mary's velocity is 54.409 meters per minute over the time interval 5 to 15 minutes. So you would need to add that. That would be an important thing to add to your answer. And otherwise, they might dock you a point, because it is only over the time interval 5 minutes to 15 minutes. It doesn't tell you anything about 0 to 5 or 15 to 20. Let's take a look at part B. So at time t equals 10, is Mary speeding up or slowing down? And give a reason for your answer. So kind of got to think back to particle in motion. And when velocity and acceleration, when they are going in the same direction, so I'm accelerating in the same direction as my velocity, then I am speeding up. When they are going in opposite directions, so opposite directions could mean velocity is increasing and acceleration is decreasing, or it could mean that velocity is decreasing and acceleration is increasing, then I am slowing down. And also I guess I should add here, velocity and acceleration could be going in a negative direction, but both in the same direction, and I would still be speeding up. So the way I like to think about this is if I'm driving a car. So if I'm driving a car at, just say, a flat 65 miles an hour, and then I step on the gas and I start accelerating, well, my acceleration and my velocity are both going in the same direction. I am speeding up. But if I'm driving along at 65 miles per hour and then I step on the brakes, that is decelerating. That means my acceleration is going in the opposite direction of my velocity. So even though, like when I step on the brakes, I don't instantly stop and start going in the opposite direction. I slow down. I go from 65 to 60 to 55. So that is when my acceleration and my velocity are going in opposite directions. So at time t equals 10, is Mary speeding up or is she slowing down? Well, we need to remember that I can have a position function, and the derivative of position is velocity. That's the rate of change in my position. And the derivative of velocity is acceleration. So if I find the derivative of each of these, I'm going down the ladder. And so I know what the velocity is. Mary's velocity is this right here. This is what they gave me for her velocity. They have also told me, and this is very important, that both Mary's velocity and Chance's velocity are positive for the whole time interval that we're considering. So I know already that velocity is positive. I just need to find out whether her acceleration is positive or negative. Well, acceleration is a derivative of velocity. So let's pull up the old calculator here. Come on, calculator. Oh no, that's the wrong button. So here's the calculator, and I just need to find out her acceleration. So I need to take the derivative of her velocity. So alpha f2, I'm taking the derivative, which is 3, and that's a derivative with respect to x. And Mary's velocity is in y1. So I'm going to go alpha f4, y1, and I'm going to find it where x equals 10. So I press enter, and I find out that her acceleration, which is the derivative of her velocity, is negative. So if her acceleration is negative, but her velocity is positive because they told us that, then Mary is slowing down. And the reason for my answer is that her velocity is positive and her acceleration is negative at t equals 10. So that's part B. So let's take a look at part C. Is the distance between Mary and Chance at time t equals 18 increasing or decreasing? And give a reason for your answer. So I got to give a reason. It says give a reason. So initially when I started thinking about this, I thought I was going to have to get into finding their positions at different times. So I thought I was going to have to find the integral of velocity. In other words, going up the ladder instead of down the ladder. But then I thought about it a little bit more. And I thought, well, if I'm going at a velocity of 10 miles an hour and you are going at a velocity of 5 miles an hour, well, then the distance between us is increasing. If I'm going at a velocity slower than yours, then the distance is decreasing. Now, I thought about that, but then I thought, so let's make a little picture of that so we can kind of see. So here's Mary. I'm giving Mary a skirt. I hope you don't find this too sexist. And here's Chance. And so if Mary is going faster than Chance, if her velocity is greater than Chance's, then you can see very clearly that the distance between them will be increasing. Except then I thought, but what if Mary is behind chance? So what if Mary is behind chance, then if her velocity is greater than chance's, then the distance between them is going to be decreasing. So I thought, oh my God, now I have to go back to this integral thing. But it says in the problem that Mary remains ahead of chance. So Mary is always ahead of chance over the whole time interval. So then I thought, oh, good, I don't need to do this. All I need to do is find out whether Mary's velocity is greater than chance's velocity at time t equals 18. So out comes the calculator. And I'm going to go alpha F4 y1. This is Mary's velocity, and I'm going to evaluate that at t equals 18. And I find out it's 18.75. And then I'm going to go alpha F4 y2, and I'm going to evaluate that at t equals 18. And I find out it's 15. Mary's velocity is greater than chance's velocity. So that means that the distance is going to be increasing. So how would I write that? So I would write something like this. Mary is ahead of chance the entire way, and since her velocity at t equals 18 is greater than chance's velocity at t equals 18, the distance between them is increasing. I will show you what the solution manual said. So this is only worth 1 out of the 9 points. They're phrasing it the point Mary at 18 minus chance at 18 has to be greater than 0. Actually, I think our way of presenting it is better because it might be less than 0, and then it would be wrong, right? But it is, and it says select the point value to blah 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 blah. The student response accurately includes a correct answer with reason, and it says required with or without numerical values. So you didn't really have to give these numbers here, M of 18, 18.751, and C of 18 at 15.047. It doesn't hurt to do it, but I think our answer is better, and I actually think our answer is even better because we have said that Mary is ahead of chance the entire way, which is important. If you didn't know that, then you'd have to do the problem differently. Part D is the hardest part of this problem, which is why it's worth 4 out of the 9 possible points. When you see the word maximum, it should bring up into your mind immediately, oh, max min. I'm looking at an extrema problem here. And if you remember, you know, if I kind of draw a little function right here, this maximum right here is where the derivative is equal to 0. Now, I'm sorry, my thing seems to be a little bit off right now. Maximums and minimums happen at critical points. And critical points can either be where the derivative equals 0, where the derivative does not exist, and at endpoints. Don't forget endpoints. Now, in most problems, you're not going to have a place where the derivative does not exist, especially in a application problem. Derivative, you might have it, but derivatives don't exist when I have vertical asymptotes, when I have cusps, when I have corners. You know, they might happen in an application problem, but typically speaking, I'm looking for where the derivative is equal to 0. So I'm going to go back to position, velocity, acceleration. Down the ladder or up the ladder. So position is related to distance. Which is the integral of velocity. So let's take chance, for example, here. Well, we're going to need to do chance anyways. Chance is starting at position 0. Mary is starting at position 12. How do I know that? Both MT, blah, blah. Mary is 12 meters ahead of Chance at time t equals 0. So they're not starting in the same place. Here's Chance and here's Mary, and they're both walking in a positive direction. And I would like to know, well, and it's both positive, so I don't really need to worry about negatives. I would like to know Mary's position at any point in time. And the way I would find, well, let's start with Chance. The way I find Chance's position is I would take the integral of his velocity, which is c of t, and I would go from 0 to some time x of c of t dt. Remember, when we're writing this out, we use different variables. This t here is just a dummy variable, but I want to find out his position at a specific time x. It would be the integral from 0 to x of the velocity. Mary's position, on the other hand, is going to be, well, it's also going to be the integral from 0 to x of m of t dt, but it's going to be plus 12 because Chance is starting at the beginning and Mary gets to start 12 steps ahead of him. Now notice that the 12 is not part of the integrand. The 12 is separate. It's 12. We're starting at 12 and then we're taking the integral of her velocity from 0 to x. Okay. So since Mary is starting ahead of Chance, the distance between them is, well, Mary's distance, and I'm going to rewrite it so it'll be easier for you to see what comes next. Mary's distance is 12 plus the integral from 0 to some time of m of t dt minus the integral from 0 to x, the same time period, of c of t dt. Mary gets to start 12 meters ahead of Chance, and we're adding that to her distance from 0 to any particular time x, going, again, up the ladder from velocity to position, and we're subtracting Chance's distance, which is from 0 to x, but not plus 12. So this represents the distance between them. So I'm going to write that down. This represents the distance between Mary and Chance. And I'm going to rewrite it even a little bit more simply because I have two integrals here, the Mary distance and the Chance distance, and they have the same upper and lower boundary. So I can rewrite this as 12 plus the integral from 0 to x of m of t minus c of t dt. That's going to be a little bit easier to work with. Because if you remember when I started this problem, we know that when the derivative equals 0, that is a critical point. And I need to find out what are my critical points where I might have a minimum or a maximum. So I'm going to take this whole thing right here, and I'm going to take it, the derivative with respect to x. Well, the derivative with respect to x of 12 is 0. And the derivative with respect to x of this integral, think about the first fundamental theorem of calculus. The derivative of an integral is simply the integrand. So it's 0 plus m of t minus c of t. I'm sorry, that doesn't look like c of t. Let's make it look like c of t. C of t. So this is telling us where we might have a critical point. What we're going to do is we're going to set this equal to 0. We don't really need to worry about where it does not exist because both c of t and m of t, they told us that they're positive. So m of t minus c of t, where does that equal 0? Well, I have to turn to my calculator to do this. And actually, if I know that m of t minus c of t equals 0, then I know I'm looking for spots where m of t is equal to c of t. In other words, where do they intersect? So I'm going to my calculator, and I have them both in my y equals, which is really helpful. And so I would basically start by going zoom 6. I always like to do that to get started on a graph. And oh, I see that this is not going to be very helpful because all I'm seeing is one of the functions, and the other one I'm guessing is probably, well, it's much farther out. So I would start by changing this. The first thing I would change is my x-axis, because I don't care about all this negative stuff. There's no such thing as negative time. It goes from, I want to go from 0 to 20. So I go to my window and I make my x min 0 and I make my x max 20, and then I hit graph. And I can see now that this is going up here and it's way up here someplace, and then it's coming down. So I think what I would do is I would see if I can kind of just figure out a y value that's up high enough where I'm going to be able to see the full graph. So I would go back to my window. I would make my y minimum 0 because I know that they're both they're both positive velocity. They're both going in a positive direction. And I don't know, it looked like it went pretty high. I'd make my y maximum 100. Oops, not 1,000, 100. Let's make it 100. And I press graph. Oh, well now I'm seeing both graphs now, but I still need to go a little bit higher. So let's go to my window again, and I'm going to make my my y max 200. And I press graph. And now I can see that I have 2 intersections. So I need 1 intersection. I'm going to go second, calc, intersect, which is 5. And it says, okay, first curve, that's fine. The blue one, second curve, the red one. The red one is chance, and the blue one is married. Not that makes any difference. And I hit enter, and I don't want to make a guess. So it gives me 1 intersection is 16.71462. So I'm going to write that down in here. I'm going to go 1 is 16.71462. But I saw that there was another intersection as well. So I need to find that one as well. So I'm going to go second, calc, intersect. And I'm going to move this cursor like way over here. Come on, move cursor. There we go. Come on, move. Oh, I have to keep tapping it. You know what? I'm going to make my first curve. Well, okay, I do have to move it over. I'm sorry. I have to move it. I have to move it closer to the other intersection. So my first curve is going to be the blue one, and now I might even make it on the other side of that intersection there. There's my blue one, and then let's enter. And my second curve is right below it, so that's pretty good. I hit enter again. I don't want to make a guess, and I get my other intersection at 4.583. So I'm going to write that one down. 4.583. Was that the full number? 6246. I'll write down the whole thing. Okay. 6246. So those are two choices, but don't forget about the endpoints. One endpoint is 0, and the other endpoint is 20. So remember now, what we are evaluating is the distance between Mary and Chance. We want to find out when that distance is the greatest. And that distance can only be a maximum or a minimum at the endpoints or at the critical points. So all I need to do is make myself a new function. So I'm going to go y equals, and that function, which I'm going to put in y equals 3, is going to be alpha f4 y1 minus alpha f4 y2, m of t minus c of t. So that's good. Now I'm going to go back to my main screen, and I'm going to evaluate each of those 4 points. So alpha f4 y3, and I'm going to evaluate that at 0, because that's my one endpoint, and I get that number. And then I'm going to go alpha f4 y3, and I'm going to evaluate it. Well, my second one was, what was it? It was 4.583. That's close enough. 4.583. So I'm going to, wait, come on, calculator. 4.583, 4.583, close my parentheses, and I get, oh, I have to stop. I made a mistake. I don't want to evaluate, and I'll make note of this in the notes there. I don't want to evaluate this at my critical points. I want to evaluate this at my critical points. I need to evaluate the distance between them now. I know that the maximum or the minimum distance between them will happen at these times, but what I want to evaluate is this function, not m of t minus c of t. M of t minus c of t just gave us these critical values, but this is the function that represents the distance between them. So let's go back. I want to put it into my calculator as this. y3 equals 12 plus the integral from 0 to x of m of t, which is y1, minus c of t, which is y2 dx. If I put it in that way, then, because that, again, is what this is right here, and the calculator will accept x as the upper bound variable and as the part of the integrand. Excuse me. So now I can go back to my main screen, and I can say, well, at so alpha f4 y3, and I want to evaluate that first at 0. And I find out that the distance between them is 12 at 0, which makes total sense because Mary is 12 meters ahead of Chance. And then I'm going to do alpha f4 y3, what was it, 4.583. So back to the calculator, 4.583. And that gets me 365 meters. Then I'm going to do alpha f4 y3, and what's the third critical point was 16.714. 16.714. and I close my parentheses, and that's the distance between them then, and then alpha F4 Y3, and I got to do the other endpoint, which is 20, and I get 27. So clearly at 4.583 seconds, minutes, the distance between them is the furthest. It's 365 plus meters. So if I'm going to write that out, if you were doing this on your FRQ sheet, you would probably put a little table. So 0 and 12, 4.583, 365.527, at 16.714, 13.344, and at 20, 27.01. So you would be identifying this time, the maximum distance between Mary and Chance over the time interval is 365.527, and it happens at 4.583 minutes.